Assalamu alaikum. Today's video I will disclose about what is encoder, different types of encoder and application of encoder. An encoder is a device that is used in many industries to provide feedback. In the most basic terms, an encoder, regardless of the type which we will cover later, sensor positions, directions, speed or counts. Encoders will use motion under a variety of technologies and translate it into an electrical signal. That signal is then sent back to a controlling device such as a PLC and is interpreted meaning scale to represent a value that will then be used within the program. Some of the technologies involved in encoders are magnetic, mechanical, resistive, and optical. Optical is the most widely used encoder motion translating technology. There are different types of encoders such as absolute and incremental. We will describe those detailed in future lesson. But for now, an example of an incremental optical type encoder uses a beam of light that passes through a disc that has opaque lines in a specific pattern, somewhat like the spokes of a wheel. On the other side of the disc is a photosensing device that will interpret the light based on the pattern of the disc. Picture a shooter blocking and unblocking the light. The pulses of light are then converted to an electrical signal to be sent back to the processor. Thus the encoder's output. Encoder have a wide range of uses which include closed loop applications such as servo or VFD control, measuring and counts. Here are some examples of process that many use an encoder. For VFD control, you may be running a pump on a VFD to fill a tank full of a liquid. You are requesting a certain speed and want to verify that the pump's VFD is at the requested speed. An encoder on the VFD may be used for feedback of speed. Next, let's give an example for a measuring process. In this application, you will need to cut some aluminum product to a particular size. You are passing a long roll, meaning hundreds of feet of the aluminum sheet, thus a cutting mechanism. You need to determine the amount of aluminum feet so that you can cut the sheet to proper size that will be used in a separate manufacturing process. An encoder attached to the conveyor and reading the material that is feeding those your cutting assembly will include the length of material that has been fed since the last cut. That feedback can then be used to adjust the cutting blade to sever the length required. For an example of counts, consider this process. You have a conveyor line that has bottles running on a conveyor. They are counted by a photo eye sensor when entering the assembly. They have a cap with an aluminum tamper-proof foil on top that needs to adhere to the bottle. Once the foil is sealed, the bottle will when moved down the conveyor line and verified that is exited the cap sealing assembly via an exit photo eye sensor. Some of the requirements for this station are the same number of bottles that enter the assembly must exit in a predetermined time frame. The bottle must not remain in front of an entrance or exit sensor. The bottle must not be exposed to the inductive sealer longer than a predetermined amount of time. You must make this assembly flexible enough to handle many types of bottle and entrance and exit sensor placement. Consider a prescription bottle, easy right? No handles, just a bottle that is a standard size. Now consider an interface bottle with a somewhat small cap and a very large handle. How in the world are you going to meet the requirements for this machine and remain flexible? If you put a pill bottle in a easy pass right, bottle in, seal, bottle out, no sensor blocked. If any of the requirements fail, bottle in, seal, tips over and is not count out. Machine helps on alert an operator of a malfunction. How about the interface bottle? Bottle in, cap passes in front of an interface sensor. Bottle counted, then the handle. The system falls because it sees a blockage at the entrance. How do you tell the machine that this is expected behavior? An encoder of code and a selector switch for a setup mode. To set up, insert your product, in this case the interface mode. You make sure to feed cap first and it must contain a foil. Your program reads an antennas on the sensor and records an encoder reading as well as determine that this is a cap and records that fact. Your program then records another antennas and determines that is not cap and must be some other acceptable part of the bottle, possibly a handle. The single bottle continues down the line where the exit sensor is triggered. At the point you again record the encoder value. You now have an encoder count that registered that the antennas or exit. In this code, you subtract the antennas from the exit and you have a bottle count.